Now we will apply KVL in the next super mesh. So KVL in super mesh 3 4. So this is mesh 3, this is mesh 4. Let's apply KVL in this super mesh. If I start from here, it is 6 ohm. I'll then go through the next mesh through which I travel through this 1 ohm, 2 ohm, and I come back. So this is going to be my complete super mesh. So let's do it, everyone. First resistance is 6 ohm. I'm traveling towards right. The current through 6 ohm is also I3 flowing towards right. So in the direction of current, drop is negative minus 6I3. Okay, next is drop across 1 ohm resistance. Through 1 ohm there are two currents flowing, I4 and I2. Now if I define current flowing towards left, then it will be I4 minus I2, because I4 is also flowing towards left, and because we are also traveling towards left, the drop will be negative, so it will be minus 1 into I4 minus I2. Next will be current through 2 ohm resistance. I3 is flowing towards left and I1 is flowing towards right. So the overall current that I can define through 2 ohm resistance towards left this time will be nothing but I3 minus I1. So the drop will be minus 2 into I3 minus I1 equal to 0. Now just to give you an understanding on one more point, I can write the same KVL equation in one more form. So what I'm doing is I'm writing the same KVL equation once again to discuss one small important point. So we are going towards right again, so it's minus 6I3. Now suppose you might be having question that why every time we define current through one resistance towards right and then towards left. We simply do it so that we get the current direction same as the mesh current direction, but it's not required. Suppose for example, when I write this KVL, I could have taken current through 1 ohm as I2 minus I4 also, which we have used before. So if I do that, if I take current through 1 ohm resistance as I2 minus I4, then my drop will be 1 into I2 minus I4. But what about the polarity, whether it will be positive drop or negative drop? Because I2 minus I4 flows towards right, and because when we apply KVL we were traveling towards left, whenever you travel in the opposite direction of current, the drop will be always positive. Similarly, if I write drop across 2 ohm in the form of I1 minus I3 and not I3 minus I1, then this drop will be 2 into I1 minus I3. And now please understand that because this current is flowing towards right and we apply KVL traveling towards left, the drop will be positive. This is also perfectly right, and just because of that you can see both the equations are same. If I take minus common from here, it will become I2 minus I4, and that minus and this minus will make it plus. Similarly, if I take minus common from here, it will make it I1 minus I3, and that minus and this minus will make it plus 2 here. So both the equations are exactly same. So henceforth choice will be yours. If you want to define two different currents and write voltage drop accordingly, you can do that, or you can stick to the same current. Whenever you are in the direction of current, drop is negative, and whenever you are in the opposite direction of current, drop will be positive. Okay, now let's simplify this. First I write down I1 term minus plus 2 I1, then I2, which is here, minus plus I2. Next is minus 6 minus 2, which is minus 8 I3, and minus I4 equal to 0. So this is my third equation which we have got, and I'll now get one last equation which will be from 15 ampere current source once again. So from 15 ampere current source, this time you can see I3 is flowing in downward direction, I4 is flowing in upward direction, and 15 amperes is also flowing in upward direction. So 15 will be difference between I3 and I4, but because I4 and 15 amperes are in the same direction, it will be I4 minus I3 equal to 15. So that's my equation 4. Now the problem is we can't solve 4 simultaneous equations easily. Hence we will have to first convert them into 3 simultaneous equations. That is possible if I simply get rid of I4. You can see that from this equation, I4 is equal to 15 plus I3. What I'll do is, I4 is 15, I've sent this minus I3 on the other side. What I'll do is I'll take this and put it in equation 3. Putting in equation 3, we will get new equation 3. Let's see what will that be.